Hello guys. If you watched my last video, why are you here? You gained nothing from that. There was absolutely no reason to click on this video. But thank you anyways for the free view. Today, I'm going to be doing this problem. Now, I actually learned this problem the same day that I did the video for the one yesterday. And I have not reviewed it since. So, but we ball. So, hopefully, I kind of understand or remember how to do this. So, find the general solution to the equation u derived with respect to x times plus 2 times u derived with respect to y plus 2x times y minus u equals 0. Now, if you, for some reason, are taking this class or a class similar with it, or you have taken a class like it, you'll recognize the form AUX plus BUY plus CU equals 0. You will recognize this form. Okay, so good. We have some characteristic equations to get from here. Awfully convenient, right? I'm just going to write characteristic equations. I'm also using a different pen, so my terrible handwriting is going to be exposed today. I don't care. You shouldn't be watching this. Equations. Sure. dt dx Nope. I think that's wrong. Going to have to look at my notes. Let me do that real quick. Everything has fallen onto the ground. Rip. Ah, it was S. Close enough. I also did it backwards. Whoopsie. dx ds equals A. dy ds equals B. du ds equals negative cu. And also note here that u is a function of x and y. Wonderful. So, we can actually kind of already see that dx ds here is just 1. Okay, if we go back to the original equation, you can just put a 1 here. This shows us that if we integrate this correctly, that x equals s plus c, or c1, which will also show us that s equals x minus c1. Following the same thing with b, dy ds equals 2, showing us that 2x, sorry, that should be a y, 2y equals s plus c2. I'm sorry, this is wrong. I really needed to study this problem more, didn't I? Y equals 2s plus c2. Right, because you're integrating with disrespect to s, so that would take it. That makes sense. Showing us that c2 equals 2. No, we're solving for s. Dude, I don't know what I'm doing. Wait, what? We can plug in s from the s we got here to get y equals 2x minus 2c1, but 2 times a constant is still a constant, so we'll just call it c1, equals c1 plus c2. So now I'm bored. Let's just call it c. Wonderful. Okay, and this shows us that c is equal to, I should be studying for a test right now, you know that? Like, I have a whole other test I actually have tomorrow that I should be studying for. But I'm making this video because it's kind of funny. You will not gain anything from watching this, but you are watching it for some reason. Why are you doing that? So, I actually don't want to call this C anymore. At least that's what I did in my notes. So we're actually just going to call this letter. I don't know how to pronounce it, but yo, check out that drawing. That was like a baller drawing of that letter, actually. What? Now for DUDS, which is equal to negative CU, as we have in our characteristic equation here. Right here. Let me put it in a fun color. Someone suggested purple to me. Boom. Okay. We'll get negative CU, which is equal to I made a mistake. I'm sleep deprived. This could actually be better written. Gosh, at least the first one didn't make any mistakes. Now this one, I'm really wasting your time, yeah? I have a whole test to study for. I'm doing this. That's kind of crazy. Y minus 2x. If you caught that, good job. You know. So anyways, negative CU. So call this C, of course, because that's how the equation fits. It's actually just equal to this. Conveniently also named C. It's a different thing. Don't worry about it. So we can actually just call it this. Okay. Evaluating this. We'll get a new C, not to be confused. I know it's a little confusing, but it's a new C. Here, I'll even call it K for constant K times E to the power of times E to the power of phi s, or whatever this letter is. I'm going to just call it phi because my teacher that does these, I'm pretty sure he has a speech impediment. And he does a great job explaining the problems. Like, we went over the problems today, and it was great. But I cannot tell what he's trying to say when he's saying this letter, so I honestly don't even know what it is. So yeah, this is what you get when you solve for du with respect to s. But remember, s is actually secretly x minus c1, and this phi thing is this. So let's rewrite this. U is now equal to k. I just said I would rewrite that. Y minus 2x times x minus c1. Okay? Now you may not be satisfied with this solution, and that's fair. Why would you be, right? Because the solution's stupid. Why is it stupid? Well, let me tell you why it's stupid. I like the color green. Let's use that. Yo, that was like... Yo, wait, is there a way to, like, see the hex code for this? Because this looks like actually just perfect green. Wait, what? That's insane. Anyways, we got a constant here and a constant here, and I don't like constants. So, low-key, let's just get rid of them, right? That's what I think. That's what I think we should do. So, let's declare a function capital F of phi, okay, which is actually equal to capital F y minus 2x. This essentially will just get rid of these functions, not functions, I'm sorry, these constants. We'll get rid of these constants. Okay. So, yeah. pretty much the whole point of that constant. I mean, it really doesn't do anything else because we can't get a definitive answer. We don't have any boundaries on our DE, so we kind of just have to live with it. So, just rewrite the function without any constants. And here's your answer. I ran a little long. The recording's 10 minutes, 25 seconds. And I low-key didn't want it to go that far. I wanted it to get 10 minutes and 1 second like all the cool YouTubers do. But, dude, I have a test tomorrow. That sucks. I haven't even studied. I mean, it's a pretty easy class, so I shouldn't have to study too much, but... Are you even listening? Do you even care? Genuinely.